Hey y'all, it's Russ, and I've been recommending this game to my 252 students for several years because I think it's just a fascinating way to look at a computer. I don't know how loud the music is. Hopefully, it's not too bad. Uh, this is a cute, fun little game, but it's also a great way to just kind of get your mind around how basic assembly is. Um, so obviously, the assembly language they have in here has nothing to do with real assembly language that we're going to use in our class, or what runs in your actual computer. But it's a simplified model that I think actually gives you a pretty good feel for um, the sort of problems you have to address in assembly. So I played this a long time ago, but it was um, right. Did I put my name there? Yeah, I played this a long time ago, but apparently it was on a different computer. All right, so cool. So basically, well, it's there. You look like a instruction follower. All right, the job on the side. Remember, you can always okay. So the idea here is that this little guy is going to represent your computer, and you're going to give a program that's just going to run repeatedly here. And so you can give him an operation like inbox, which just means we're going to read out of the input, and then we're going to write to the output. And when you hit the bottom of this, in this game, what it does is it just loops back up to the top. You can just see he'll grab it, he'll go put it in the output. Not enough stuff in the outputs. Oh, I thought you had a loop. I guess I'm mistaken. All right. We got to do that more times. All right. And you can then speed it up so he. Oh, silly me. I'm thinking about what I'm talking rather than what's actually going on. All right, cool. All right. So what do we have here? All right. We got a jump command. So jump, this is what allows me to do it in a loop. So now we can say input, outputs, jump, and put the destination here. And then we'll just run it. Oh, this is a cool thing that I forgot to mention to you. Here, you've got a play button. You've also got step forward and step backwards buttons. So you can go through one by one to see what he's going to do. The inbox method, of course, grabs something. Outbox is going to write to it. And then we can just run it. We'll run it max speed. It'll run pretty quick. All right. All right. Just send the following 3 letters to the outbox. BUG. Some items, if there were only a way you could pick them up. Oh, okay. Yeah, so you could do a copy from. All right. So you can, here you want to put the letters BUG out there, but your inputs are not going to work. So copy from is basically a way of reading from main memory. So you can do a copy from, select B, copy from U, copy from G, and we'll need to outbox each of those. Go ahead and run it. So this is basically just reading main memory. All right. All right. The data won't collate. Grab the first 2 things from the inbox, drop them into the outbox in reverse order. Repeat until the inbox is empty. So now what we need to do is we're going to need to read something, store it, and put it someplace else. Now, in something like the MIPS processor, we've got a whole bunch of registers. So you can copy something into a register and have a bunch of registers active at the same time. But in a model like this, you've got very, very limited memory. You can only hold one thing at a time. So we can't hold 2 things and then like swap hands. That's not going to work. So we'll inbox, and then we'll copy to 0. We'll then inbox again, outbox, copy from 0, outbox that, and then jump up to the top. That should make it work. There you go. All right. And I am not going to show the videos here because it does have a little bit of a story and I don't want to ruin it for everybody. All right, so I couldn't find any way to skip the video, so I guess I'll just cut it out of my recording. And let's see here. For each two things in the inbox, add them together, put the result in outbox. Got a new command. All right, it adds the contents of a tile on the floor to whatever value you're currently holding. What I wish I could do, of course, is I wish I could take whatever I'm holding and read it out of and add it to whatever's in the inbox. And you could imagine a processor that does this, but that's not what they decided to do. Instead, you're going to do it inbox. You're going to copy to 0, then you'll inbox again, and then you'll add what's in 0, and then outbox the result, jump up to the top. And we'll do that. All right. All right. Tripler. All right, let's try this. All right. Okay, for each thing in the inbox, triple it and outbox the result. All right, so we'll inbox something. Now, we need to triple it. We need to add it to itself. So we're going to have to copy it to element 0 and then add. Now, if we do an add right here, we're adding it to itself, so that's twice. If we add once more, we'll get 3 copies of it, or 3 times the original value. So if we play this, all right, so we inbox something, we write it out, we add, we then add again, we then outbox the result. Looks like it should work. So here, we've not been given a multiplier. We've been given just adders, but we can build multipliers out of it. All right, so this is something where this gets really interesting because not only do they ask you to solve it, but as we get more advanced, they're going to give you challenges about can you solve it with a certain performance? So can you do it with a very small program, or can you do it with a very fast one? In this case, it was very easy. So octuplier. All right. All right. Multiply it by 8, put the result in the outbox. All right, so we could do this before. This is inbox, copy to 0, add 0, add 0, add 0, add 0. Now this is the wasteful version. I need to do this 7 times. Then we'll jump up to the top here. So if we do this, we run it mid-speed. Oh, I forgot to outbox. All right, so what it says, we used too many commands. We completed in 36 or fewer steps. So let's see what we can do here. Do we have something? Yeah, so we can do this with smaller number of steps. Eventually, they will allow you to do comparison, conditional branches. Then you could do looping, but we can't do looping yet. So what we'll do here is we know that this add operation basically doubles it. So we can copy to 0 and then just do another add. And so if we've got the original value, here it's worth twice as much. Here we've quadrupled it. So let's copy 2 again. And now we should be able to run it. Smaller program, and it's faster. Now this is a cool thing that you'll see in assembly where the smaller program is also the faster program. That's not always true. All right. What does this do here? For everything in the input inbox, multiply it by 40 and put the result in the outbox. All right. Well, you can't do powers of 2, but this is something you can do sometimes, where you can multiply by things other than powers of 2 by having multiple copies of it. So I'm thinking if we knew what 5 times the value was, it would be easy to do. If we knew, but how do we figure out what 5 times the value is? Obviously, we could do add a couple of times, but I think what we can do is we can do something trickier than that. Let's inbox something. Let's do a copy to 0. And then we're going to copy 2 again to 1. All right. Copy to 0 is going to be our accumulator. It's going to have our total. Copy to 1 is going to have a pristine version of it. All right. So let's do an add 0, and then we'll copy to 0. So now what's stored in 0 will be double the input. We can do an add again. So now what we're going to hold is 4 times the input, and now we can add 1. That gives us 5 times the input. Then we'll do a copy to 0. We're going to overwrite 0 and 1 now because we're just going to be doing multiply by 8. Copy to. This is going to give us 20. That's so that's 5, 10, 20, 40. And make sure you outbox it, Russ. There we go. Actually, I should do this slower so you can see it. All right. We inbox something. We store it into 0. We store a pristine copy into 1. We then add it together. So now we've got 2 times the input. Store it in. Now we've got 4 times the input. Now we've got 5 times the input. We could store that away. Now it's 10 times the input. Now it's 20 times. And now it's 40 times the input. We outbox it, and we're golden. Now, somebody could do this in 14 or fewer commands. 56 or fewer steps. All right, well, let me look. My guess is that maybe we're inefficient here. We did a copy to. We're going to have, that's definitely we'll have to do. Did we need to copy into? What if we just did the add? Is that quicker? You know, actually, for a small multiply, that might be faster. Yeah, because we just have to do 4 adds in a row. Okay. That's actually simpler. That'll save us 1 instruction, and it'll save us the 4 clock cycles. Again, we've got an example here where the shorter program is faster. That's not always going to be true, but it is true somewhere. 0 Exterminator. All right, I think I'm going to show. I think this is where they introduce conditionals. And if so, I will show you this, and I'm going to stop after this. Send all things that are not 0 to the output, to the outbox. So this jumps only if the value you're holding is 0. Otherwise, it continues to the next line. All right. So we'll inbox it. Now, what we're going to have a conditional branch here. And so our core is that we're basically going to have a loop that looks like this. inbox, output box, jump up to the top. We've seen this before. But we want to have something where we want to say sometimes I don't want to actually outbox. So you can use a jump if 0 here. Now, there's two ways you could do this. I'll start here. This is the idea of jumping over the outbox instruction. And this is probably the best simple way to think about it. So if we go here, we'll inbox something. We then did a jump if 0. But you'll notice he looked at his value. It wasn't 0, so he didn't jump. Instead, he outboxes it. And then he jumps up to the top. Inbox. Jump if 0. So he's going to jump over the outbox instruction. Now he's just throwing it away because we inbox another one, he'll throw it away. There you go. Okay, so this is going to work. It's not totally optimal in terms of performance. So what they'll show you here, 4 or fewer commands, we succeeded, but our speed was slower than we needed, or slower than was optimal. All right, so how can we make this faster? Well, what I notice here is that when we jump over the outbox, we're jumping to a place where we only jump again. So the way we've drawn it here, I actually think is a really good way to do it in terms of a good way to think about things, because we've got nice contained elements. But what I notice here is that I could just jump up here so that we immediately go and inbox something new. And that's going to be a hair faster. So we will outbox. We jump up to the top. We'll inbox another one. Now we're going to jump if 0, so we'll go back up to the top. Throw that away, get another one, and we'll run. Now, I'm not totally sure how the clock model works on this, but I believe that this might be suboptimal. Let's see how they count it. Oh, no, they didn't. They counted it that way. All right, so this is conditional operations. Oh, didn't mean to do that. I wanted to... How do I get past this? Oh, there we go. So this is... All right, so this says only send the zeros to the outbox. Later on, they'll get to things like, compare two numbers, and if it's positive... Actually, I think they don't compare two numbers because you never have two numbers. I think they do if the number you're holding is positive or negative, jump somewhere, which now allows you to subtract two numbers. And if the result of subtraction is positive, go one way. If the result of subtraction is negative, go a different way. So anyway, I think that's enough to show you what the game's about. I don't want to spoil the whole thing for you. So I would highly recommend you go get this. In fact, I would get anything from this developer. They seem to do a whole bunch of real quirky games that are a lot of fun to play. And some of them are actually very educational. Not all of them, but a few. Anyway, I hope this was interesting. I hope you learned a little bit about assembly language, and I'll see you all later. Bye-bye.